Hello everyone, I hope you're having a good day. Today I'm going to be talking about modularizing our applications for scale and how we at PhonePe divide them for better efficiency, for better scalability, and for better release cycles. My name is Bhagat and I work at PhonePe as an iOS engineer. PhonePe is India's payments app and it is revolutionizing cashless payments across the country. It was the #1 ranked finance app in the App Store as on November 1st. I also contribute in ravendlick.com tutorials and books. So ravendlick.com is the world's leading authority on mobile and game development tutorials. So let's get on with it. So it's somewhere in 2016, PhonePe is just starting out, and this is a very early day screenshot of what PhonePe started out as. As you can see, it is a handful of use cases. PhonePe was leveraging UPI, or Unified Payments Interface, which is regulated by the Government of India, and it is a safe and trustworthy way of transacting cashlessly across India. The major use cases that PhonePe offered at that time were P2P payments, which meant sending or receiving money from your friends and family, a recharge category, which included data card recharges, DTH recharges, stuff like that, and utility bill payments such as water, electricity, and gas payments. And now when you look at it, and I'm sure you might have it in your mobile phones right now, it offers around 40 plus use cases. For example, selling gold, building a network of ATMs, selling mutual funds, insurances, stuff like that, and virtually any use case you can imagine with UPI. So what made this transition happen? It seems magical, doesn't it? But it is not. It is a collective effort of around 60 plus developers spread across 4 years of time, releasing, debugging, and coding the app. And we're not even considering the time involved with product managers, with designers, and also QAs and analytics team who strive every day to make the product better. On the iOS perspective, it is a collection of around 32,000 commits almost, and as I speak, over 100 versions of the app. This is just to put things in perspective of what the scale and size we are working at. But this doesn't stop here. With all the new shenanigans in the market, we had all the things coming our way to handle complexities. For example, we had to integrate React Native, we had to do an Objective-C interop, we had to do a third-party framework integration, and recently we added a Kotlin multi-platform integration. Now every sweet success story is flooded with problems, and we sure as hell were not an exception. We've had a fair share of our problems, whether it is scaling the app to the next million or something more relatable to us developers, like shipping faster, automating releases, stuff like that. Now I want to highlight some problems in detail so you get the idea of why we do what we're doing right now to manage our releases. So the first one would be merge requests. Merge requests are a key way on how teams work and ship their products. Every process revolving around merge requests is far from ideal, and it takes tons of time to inculcate healthy merge request practices in a team, whether it is coding style or the approach to a problem. Now when you're nearing a release, every developer rushes to get the code merged in, right? Everyone is trying to get through that door, which of course will cause a collateral damage. Ultimately, this results in at-par code getting merged because of the release pressure and adding some things to the tech debt that we are sure as hell not going to visit again, which at a later stage becomes completely unacceptable because it causes the health of your application to degrade and ultimately in the long run harms the application. Next up would be reverting changes. So suppose you got a shiny new MR merged into a master, and now the backend guy says, hey, something happened, I cannot deploy my code, you have to take back your changes. Now you're stuck in a loop when you just got your code merged and you now have to revert it back. Now, as luck follows us everywhere, it always ruins a Friday for a couple of folks who don't even want to be there. And the release manager is kicking himself that he was the manager managing the release this week. The next thing that comes up is merge conflicts. Now, in my personal opinion, merge conflicts should officially be renamed to headaches, because you don't actually know who did it. You sure as hell don't want to break the project. You just want the project to compile, and as the sincere developer you are. Now, as a result of all the above factors, you get a fourth point, which is a choked CI machine. When this guy breaks something, all of these people have to wait for his code to succeed, or if not, your code is running parallelly with everyone, so your CI machine is processing multiple builds at a time. Everyone is waiting and waiting and waiting, and then you get a release delay. So when a release gets delayed, there's a lot of strings attached to it. We as developers are sometimes agnostic of this fact that what business decisions have been made prior to that release. Maybe there's some TV PR done, maybe there's some printing PR done, so we never know. And that is why business never understands. Now, all of these reasons combined, there was one thing that was very clear: things have to work efficiently. So we arrived at 4 problems to solve. The first one was we should be able to release at any time possible, whether it is a crazy business requirement or a hotfix. The second one is our releases should be as independent of our business use cases as possible. The third one is we should be able to roll back any changes that were done to the project easily in case of emergencies, in case of hotfixes, etc. And we needed faster release cycles because building a feature was not something that was mattering. It was getting it into the hands of the users. So we decided to streamline the process and come out with a concept of a train. Now, trains are actually not new. I'm sure most of you must have heard of it, but we've renewed it based on our expectations, our working environment, and our priorities. So there would be 2 trains a month of 15 days each, and it would include 7 days of dev and 7 days of QA. And the basic and foremost necessity to enforce the system is a strict timing guideline in place, which everyone has to follow religiously. It is because everything that you need to make that shiny new feature should already be in place by then. Whether it is your backend API on a staging, or a UX decision that was pending on some product manager, or a design requirement that had to be fulfilled. So it basically gives everyone time to get their things done. It gives devs the time to code and dev test their features, and it gives enough time for QAs to perform a sanity on the flow with all of the things that they have in place. And if someone is working on a feature that cannot catch this train or gets delayed due to some reason, there's always the next one. So this is typically how a train timeline looks. Basically, let's assume that November 1st is a Monday. Then I get 5 working days to work on my feature and get my job done. All the while, QAs are busy testing previous backlog features or previous build sanities or some edge cases, upgrade scenarios, and all of that. Then November 6th to 7th would be the weekend, and when I go into the next phase of November 8th, I'll give my feature to QA to test it again, and they do it throughout the first 3 days of the week. Then on the last 2 days they do integration testing and for critical bug fixes. Now there are some timelines involved that everyone has to take care of. For example, backend APIs should be available on stage before I start working, and November 5th should be the last day to raise my merge request, or any 5th working day of that train should be the last day to raise my merge request. Stuff like product and design acceptance happens in parallel with feature testing, so that can also be accommodated in that. And more stuff like code reviews, QA sign off, backend on production servers, code freeze, and if there's a huge feature going, a beta if possible for that. Now by the time our previous app or the previous submitted app is in store and it is 100%, we have another app already ready, right? So that makes sure that we are always shipping. You must be like, yeah, I have a similar process at my own company. How does it help me redefine what I already have? So actually the first step would be to divide user flows into teams, and by teams I mean folks dedicatedly working on that flow. Now when we went on to divide user teams into flows, we went out with a structuring like this. So for example, we had a P2P, we had a switch platform, we had rewards, and we had an insurance platform, and then we had taxes, water, loans, payments, offers, and God knows what not, right? On and on and on. We had a ton more, and we have like a ton more in the pipeline as well. So the first thing that you get when you divide these up is you give the full ownership of the code, of the timelines, of the features, and of the testing and the health status of that feature. So we divided them using Cocoapods, which is a dependency management framework for iOS platform. And when you do this, your main app just becomes a shell which comprises of different use cases. So basically this is what your pod file looks like. You have different use cases, segregated pods listed in the pod file. You have different versions listed out of your pod file, which specifically that pod has released for usage in the main app. Now when an MR of a certain pod gets merged in their repo, they simply have to just bump up the version number of their repo and it starts working, right? So we like to call them microservices because they make their own decisions. We don't like to call them pods. Whether it is a database, whether it is a networking decision, or whether it is a UX decision, right? So what are the upsides of using this? So basically you stick to your own timelines of code merging, of code releasing, of code strategization, of code testing, of QA testing, and stuff like that. So you'll have no more merge conflicts, and even if you do have them, they are in your own pod, so you know the context already on how to evaluate and solve that. You can run tests individually for your own module, so you don't have to wait for the whole application to run and to build. Basically you're working in a sandboxed environment where you and only you are in charge of what is happening. Plus, in worst cases, even if you have to revert your code, you only have to change your pod file, and you always have a working shipping ready copy which is tested of your code. That means you'll also have very small actually code reviews, which makes your code more robust and foolproof. You'll flourish as a developer, and when you don't have to worry about external changes, you just have to worry about creating the best user experience possible for your own module. So it is tried and tested as well. It is scalable as well, because we have 30 plus devs working on 40 plus use cases on the iOS team. And since we're talking about modularity, how can we not talk about code reuse? And since we already divided our code components into smaller chunks, other teams can use it as well to create user flows and save their time. For example, we have a business app, PhonePe for Business. We can use the same code again and again. And with the help of feature flags and configs, we can decide certain look and feel of the app. Like if we want to give a purplish color to the main app and give a green color to the business app, we can do that with the help of configs, right? It gives you cross-app stability, which is tried and tested over time and withstands all QA health checks. Now, I must say all that glitters is not gold, and same is the case with this. We have a dependency here, and which is every app depends on something like a common code or a central repo of some common stuff, which is a collection of common interfaces, common assets, common structs, localizations, extensions, utilities, and whatnot. So sometimes you'll introduce changes that are in the common code and your MR gets reverted. So you'll have to keep the common code module version number in sync. So the only thing that we tell to our core team members that manage the common code thing is that you don't have to introduce breaking changes and you'll be fine. So this was the journey from left side to the right side, done over 4 years of time with 250 million registered users and over 100 million daily active users, having 2.3 billion astonishing app sessions, and capping the market with 835 million UPI transactions with a 40% market share. So, and obviously we're just starting out. So I'd like to thank you for listening to me, and if there's any questions that you'd like to ask, I'm sure we have a Q&A session scheduled, or you can just ping me on Slack, you can ping me on Twitter for @SoulfulSwift. So thank you for listening to me. Have a great day ahead. Thank you.